In this video, we're going to use trig to solve some different types of application problems. So the first thing we need to know is the difference between angle of elevation and the angle of depression. So angle of elevation is always measured from the ground up. So if you look right here, this angle X is the angle of elevation. Most importantly, it's important to know that the angle of elevation is always measured from the ground. So meaning we're assuming that it's measured from the horizontal line and going upward to whatever the object is we're talking about. So this angle right here would be the angle of elevation. Angle of depression means you're starting at the object and you're drawing in. Sometimes it'll be drawn, but most of the time you're going to be drawing in this horizontal line because you're measuring from the horizon and measuring downward to that object. So this angle right here is the angle of depression, most commonly mistaken as this angle, but remember, angle of depression has to be measured from the horizontal line. Same thing with elevation. So they're always measured from a horizontal line going downward or upward depending on the scenario. Now, one other important thing to make note of here is that the angle of elevation and angle of depression are always going to be equal to each other. So if you look at this diagram here of a right triangle, the angle of elevation measuring from the horizontal up, so let's say that that's X, that would be equivalent to me saying the angle of depression. So starting up here from the horizontal line, measuring downward to that object on the ground, that would also be X. These two angles are always going to be equal because if these lines are both horizontal, which they will be if we're talking about angle of elevation and depression, these lines will always be parallel to each other. And then that makes the Z shape, which makes congruent alternate interior angles because the lines are parallel. So therefore, those angles will always be the same. So the angle of elevation will equal the angle of depression. This is important because sometimes they'll give you the angle of depression, which is not going to be part of the triangle, but because you know that the angle of depression is equal to the angle of elevation, we can find the angle of elevation using that right triangle and that angle, and then that'll tell us the angle of depression. So that's an important concept. And remember, it'll always be true because you're always going to be measuring from the horizontal lines, which means those are parallel. So these are congruent alternate interior angles, which makes those angles always congruent. So let's look at how we actually use these new vocabulary terms. So for these pictures, you want to make sure that you're drawing a picture so that you have everything drawn and labeled correctly so that you're setting up your trig ratios correctly. So first thing is John wants to measure the height of a tree. So I'm going to start with a tree. We want to know the height of that tree. And so let's just say this is going to be what we're trying to find. Remember, objects are going to be perpendicular to the ground. So we're trying to find the height of that. He walks 100 feet from this, so he's going 100 feet in any direction, doesn't really matter. And from the base, so he's walking 100 feet from the base of the tree, and he looks up. So it's saying that the angle from, so that means starting from the ground to the top of the tree, so from the ground up to the top of this tree here, is 33 degrees. So from the ground upwards is 33 degrees, the angle of elevation. We want to know how tall is the tree. So now you see you have a right triangle, you have an angle, and you have a side, and you're trying to find a missing side. So that indicates SOHCAHTOA, which you've seen. So if we look at our angle that they gave us, this is a 33. Label our sides with respect to that angle. So this is the opposite, this is the adjacent, this is the hypotenuse. We have nothing on the hypotenuse, and we're not trying to find it, so we won't be using anything with an h in it. So we'll be using tan. So it's going to be tan of the angle is equal to the opposite, h, over the adjacent, which is 100. Making sure you guys are writing this out. Do not forget any of these steps. You need to write your equation. Now I'm going to show the solving. So I'm going to put this over 1. I'm not going to just plug into my calculator. I'm actually going to write out my work. So the height is equal to 100 times tan of 33 degrees. I'm going to go to my calculator, make sure it's in degree mode. I'm going to type in 100 times tan of 33 degrees in degree mode. The height comes out to be 64.94075939198. When I'm in float 12 for my decimals, we want to round to the nearest foot. So nearest whole number means that's going to bump up to 65 feet. So I'm just going to say height of tree is approximately 65 feet. So this part here is the same as what you've been doing. The new part is, okay, now these are application problems. Sometimes you're going to have to draw a diagram. Sometimes the diagrams will be drawn for you. But the math behind it is exactly what you guys have been doing. So looking at example 2, it's talking about a bird sitting on top of a lamppost. So that means I have this post here. I'm not going to try to draw a lamp. I'm not that creative here. So I have a bird that's sitting up here. Here's my bird. And the angle of depression from the bird, so from the bird to the feet of an observer who's standing away from the lamppost, is 35 degrees. So we need to draw in some stuff here. We have this observer, so someone's over here who's standing away from the lamppost. The angle of elevation from the bird to the feet of this person. Not angle of elevation, angle of depression. I think I just said elevation. So from this bird to this person's feet, we know the angle of depression is 35. So that means you're measuring from the horizontal line down to that person's feet. That's 35. Remember, it's not inside the triangle here. It's from the horizontal line downward. And then you can see, okay, well, now I have this triangle that's formed. This is my right angle because it's a lamppost. It tells us that the distance from the bird to the observer, so from the bird to the observer, is 25 meters. We want to know to the nearest tenth how tall is a lamppost. So this is what I'm trying to find. I'm trying to find the height of that lamppost. So you have this right triangle. The issue is this 35 degrees is not in the right triangle. And without that being in the triangle, you only have a side and you're trying to find another side. So somehow this has to help us. And if you remember what we wrote on the top of our paper is that the angle of elevation equals the angle of depression. Well, if this is 35, so is this right here. Because these lines are parallel, they're horizontal lines, meaning these are congruent alternate interior angles. So now I have an angle, a side, I can use trig. So I know that this is going to be the opposite, this is the adjacent, and this is the hypotenuse. So I can set up, SOHCAHTOA. I'm not going to be using the adjacent this time, so anything with an A we're going to get rid of. So it's going to be sine of the angle is equal to the opposite over the hypotenuse. So again, you're showing this setup, you're putting that over 1, you're cross multiplying. So it's in my calculator, 25 times sine of 35. So we're writing that out, and now we're actually plugging in. So 25 times sine of 35 degrees is going to be 14.3394109088. And I need to follow the rounding directions to the nearest tenth. So the height of the lamppost is approximately to the nearest tenth 14.3. My units on this are in meters. So there's the answer. Now, keep in mind with these angles of depression, you could have also, since the angle of depression is outside of the triangle, you could have also found this angle right here because of the fact that since this is 90 and since these are both horizontal lines that are parallel, these two angles are supplementary. So meaning if this is 90, this whole angle has to be 90. So if I have just taken 90 minus 35, I would have gotten 55 for this angle. And then I could have used this angle, labeled this my opposite, this the adjacent, and my hypotenuse. And then my setup would have been a little bit differently. I would have been using cosine, but in the end, you would have gotten the same answer. So that's another approach that some people use. More commonly, people use the fact that these two angles are equal. So that's why I chose to go that way. So either way would work, but just remember that those angles of elevation and angles of depression are always measured from the horizontal line. So get your key ideas from the video written down and do your practice, and we will talk about those tomorrow.